Okay, kids, hello. You better believe I sat here and you know what? I cannot find a pattern that works with this first term. I sat here. Now, I maybe could sit here some more, but when I say you better believe I'm going to go and look this problem up and say, like, what? What pattern are we missing? For the purposes of just getting through to some important points I want to share with you, though, I'm just going to knock this out of the way, okay? Let's just work with this series moving on forward, okay? But man, I cannot find a pattern that makes this work. If you do, by all means share it, but listen, this is not worth our time to make this work. If you're wondering, will patterns like this be that difficult? The answer is no, but man, I am stuck in a very stubborn way. So, all right, so we're going to work with, so follow me here. For now, we're just going to work with, we're going to pretend the first term doesn't exist, okay? Can you, in working with series, just ignore a term? No, but we're doing it just for the purpose of getting to the points that I want to make with you. So I'm going to work with the series in black, okay? I'm also going to work with Leo's pattern that he found here, which, and I would argue too, seeing this pattern, even if this first term wasn't here, this being the pattern is generally speaking more than would be asked of you. Because if we start looking at crazy patterns, just the focus of the problem starts to deviate from the calculus. So, one more time, let's work with this series. We're going to take away this first term. This is the pattern. Please put this Maclaurin polynomial, since there's no dot 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 here, I want you to write the Maclaurin series, that would be the dot dot dot, okay? Don't have this term, right? This is my first term now. With this pattern, please express this Maclaurin series in summation notation. Pause me and then replay to see if you're correct. Okay, so here is my summation notation right here. I chose to start at 1. Could you have chosen to start at 0? Absolutely. You'd have to just then modify, like, all the stuff here, just like you did in the test, okay? So here's my summation notation. You're going to pause me now, and you're going to find the preliminary IOC. So once again, I know there are directions up here. We'll go back to reading the directions after you do what I tell you to do. So please find the preliminary IOC and pause me at that point. Replay me now. Okay. When you find the preliminary IOC, once again, I talked about this in class, keep it clean, keep it clean. Keep it clean, da-da-da, da-da-da. Here is my preliminary IOC. My question to you is, what do you notice, and this is something that you want to all write down and make note, what do you notice about the preliminary IOC's midpoint? What do you notice about the middle of the interval from -1 to 3? What's the middle of the IOC? The middle of the IOC is x equals 1, right? X equals 1. Let's look at the problem. X equals 1. This is a Taylor series about x equals 1. So here is something else that you are going to see. Notice that all the Maclaurin series work we've done so far, what have all the Maclaurin series IOC's midpoint been? They have always been 0. So we're going to make a big proclamation right now. This is always the case. The midpoint of any IOC is always the quote unquote point of tan. The midpoint of the IOC is always the point of tangency, or the point of attention. I'll put the point of focus. How about that? Because the focus here, right, when you're looking at a Taylor series, everything is about x equals a. A here happens to be 1, okay? So that is always the case, kids, but up until now, you couldn't appreciate that. But if you go and look at, flip through your Maclaurin series photo album, you'll notice that all the IOC's midpoint is 0. The IOC's midpoint is always the point of tan, which is why I love this. So if you look at this, right? So again, we amended the problem. I realize that. But part B says the Taylor series for f about x equals 1 has a radius of convergence of 2. Find the IOC. We found the preliminary IOC using the ratio test for absolute convergence. But now that we know this detail, guess what? If I'm ever told what the radius of convergence is, and I know what the point of tan is, I don't have to do any ratio test I don't have to do any of this. I can go right to this from this information and say, so I know the preliminary IOC has to be 1 is the midpoint, and I want to go a distance of 2 in either direction. So the preliminary IOC is going to be 1 minus 2, so -1 less than x less than 1 plus 2, 3. And that's exactly the same result we get the long way, okay? But this is a great tidbit. Now, kids, right, if you're not told the ROC, in this case, you still have to do it the long way. But this is still incredibly wonderful things to just keep in your back pocket. So please add this, highlight it, whatever you do, right? Things that deserve attention in your notes, please do that. All right, but now let's take a look at the rest of the question. It says, now we have to find the IOC. Okay, so I'd like you to find the IOC, which means you're going to now test each endpoint in the original series. Pause me now and replay to check. Here it is, checking at x equals -1. When you sub in x equals -1, we get this. I talked to you yesterday about cleaning. When you clean the numerator here, you'll notice that it cancels out, okay? Check at x equals 3. When you clean the numerator, this cancels out. And then what you've got is at x equals -1, you have divergence. At x equals 3, you have convergence. Final IOC is right here. Beautiful. Okay. Moving along, here we go. Okay, so this is kind of a similar. I am going to meet you after you have done part A. So this is part of homework. I'm just taking this off of homework since we're doing it together, okay? Be careful here, lots of reading, don't get caught up in the details. So part A is saying, show that the first 4 non-zero terms of the Maclaurin are blah, 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 and write the general term, okay? So pause me now, please. All right, so when I first kind of just set up the general first 4 terms, but since f of 0 is 0, I know that I'm going to have to go one more term afterwards. But here is f prime of 0x is just positive 1x. Let's talk about how I got this second term. This second term, and I'm calling it second because I know this is first, second, third, but the first is 0. So this term here is gotten but from here. But I have to know what f double of 0 is. So be careful. If you use this definition here, when n equals 1, f double of 0 equals n, is it n? Oh, it is, it's negative n, okay? So negative n times f prime of 0. And f prime of 0 is 1, so f double of 0 equals -1. So I'm dropping that into, this is my degree 2 term, okay? Now go ahead and find the second and third degree terms, if you want to see my work here, right? When n equals 2, f triple of 0 equals, okay, I keep saying this term is it negative n? Yes, negative n. So when n equals 2, f triple of 0 equals -2 times f double of 0. F triple of 0 is 2. Okay, so here we are. All right, and then this is me finding the first, second, third, fourth term. Now, this is the thing. I have to find the general term. Okay, so am I looking at this here? When I look at these right here, so this is what I would call a reasonable question that asks you to find a pattern. So I certainly see the pattern here, okay? I certainly see the pattern here. 1, -1, +2, -6. This is a little bit confusing. I mean, maybe some of you see a little bit of here, like maybe some of you see like, oh, this could be -3 factorial. This is +2 factorial. This is negative 1 factorial. This could be 0 factorial. And let's do it that way, right? Maybe some of you see that I could rewrite it like this. I'll do two things that I see. 0 factorial x minus 1 factorial x squared over 2 factorial plus 2 factorial x cubed over 3 factorial minus 3 factorial x to the fourth over 4 factorial, okay? And maybe some of you kind of saw that, all right? So in here, I think you can see a pattern. 3 factorial, 2 factorial, 1 factorial, 0 factorial. What I would generally do first is, generally speaking, if in the pure factorial version, in the non-clean version, so when I see this right here and I don't see a pattern immediately, generally what I do first is I generally would not do this first. I would do this first. I would first flesh this out and try and simplify it all, okay? So I would do this, and let's see what happens. So I would say, okay, let's say here, let's see, this is 1x minus 1x squared over 2 plus 2x cubed over 3, 3 factorial is 6, right? Minus 6x to the fourth over 24, okay? So now, again, so what I'm saying to you here is, I generally, if I don't see a pattern in the factorial, I just kind of try and simplify it. But I'm not done simplifying, so let's keep simplifying. 1x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4. Now I see the pattern, okay? Now I see the pattern. Now, if some of you are like racing to say, but Ms. Yam, you can still get there by here because I can simplify these factorials and I get the same thing. My point to you is great. Like either way you want to go. I wish I could tell you that one way works more than the others, but it doesn't. I will share with you that generally speaking, I find it successful that when I develop a Maclaurin, or a Taylor, I should say, a Taylor about x equals a, okay? And if I don't immediately see a pattern in the uncleaned version of the polynomial, I generally will try and bust out all the factorials and then clean it up. And usually I'm able to see a pattern there, okay? If this method fails me, then it's like you try some wild and crazy things. To be true and honest, it never gets as just wild and weird as like this pattern. This is just straight up weird, okay? All right, so now everybody, I'm gonna go ahead, now that I see a pattern, I'm gonna generate the, what is it calling? They're calling it the general term. Okay, general term, usually, okay, no, it's not usually, always, it just means put a dot, 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 and put an expression here for the general, like, kth or nth term. So I'm going to call this, let's see, x to the n over n. And again, I'm going to start, you have to tell the person where you're starting. I'm going to start it at 1. So let's see, x to the n over n, that takes care of the non-alternating, but now I've got to deal with the plus minus. So I've got negative 1 to the n plus 1. Okay? All right, very good. That was part A. Part B, everybody, determine whether the Maclaurin series described in part A converges absolutely, conditionally, or diverges at x equals 1. At x equals 1 means you're going to plug in x equals 1 and you're going to deal with that. That is old stuff. I'd like you to do that for homework. You're going to show me the work you do for part B. I'll put a little highlight. All right. Now, big takeaway number 2. So the first big takeaway in this screencast was the whole notion that the middle of any IOC is always the tangent point, or the point of interest, point of focus. Here is number 2. This is huge. Write the first 4 non-zero terms and the general terms of the Maclaurin series for g of x, where g of x is the definite integral from 0 to x of f of t, okay? And once again, this is important. It's g of x. The writer is making sure you understand that g is a function of x here. right? If they wrote f of x dx here in the integrand, it would be incredibly confusing. So the use of x versus t is someone telling you, mind you, g of x is a function of x, okay? Now, there's a wonderful shortcut I'm going to show you here, okay? This all is, let's remember, this is the Maclaurin series for who, everybody? This was the Maclaurin series for what function? This is the Maclaurin for, I believe, f of x, agreed? Part C is asking you for the Maclaurin for g of x. Okay, so let's just go down here and say, we're told that g of x is the definite integral, is it from 0 to x, is that right? Okay, very good. From 0 to x of f of t dt. And we want the Maclaurin series for g of x, okay? And if you want to write the whole story out, we can say, you know, this here, this is the Maclaurin series for f of x. I want the Maclaurin for g of x. Well, kids, what is this? G prime of x equals what, everybody? G prime of x equals f of x, right? So, by FTOC part 2, G prime equals f. So, if G prime equals f, would you agree that the antiderivative of f equals g of x? So what this is saying here is, if f of x is equal to g prime, okay, so f of x is actually g prime of x. G prime and f are one and the same. That means this Maclaurin for f, we could also call it the Maclaurin for g prime. Well, kids, I don't like that the word kids has come into my vocabulary. I'm just very annoyed at myself. All right, g of x. So what do you think we're gonna do here? If this is the Maclaurin for g prime, how would you find g? Yes, you're gonna anti-differentiate term for term. Oh my goodness. X squared over 2. Whoops. X squared over 2 minus x cubed over 6 plus x to the 4th over 12. I don't know how many terms they want. Okay, first 4 and general. Okay, let's keep going. First 4, okay. Minus x to the 5th over 20, okay? Now here, when I look at this, see, I actually just found these numbers by, right, when I integrated this, I brought the 5 down low here, and 5 times 4 is 20. I'm actually gonna do this. I want to unsimplify it, because if I have to find a pattern, I can see a pattern more easily in my unsimplified version. So this is gonna become, watch, 1 times 2, right? This becomes 2 times 3, this becomes 3 times 4, this becomes 4 times 5. There we go. Okay, so now I see a pattern. So this is the Maclaurin, the pattern. The pattern here is x squared over 1 times 2, x cubed over 2 times 3, x to the 4th over 3 times 4, okay? Go ahead and try and cultivate, develop the general term, plus ... I'm gonna call this, let's see, we gotta say where we're gonna start, right? I'm gonna start it at, okay, let's use my general term. X to the n all over n minus 1 times n. And if I write it like this, I'm going to tell the reader to start it at 2. I love that. And then the negative 1 to the n. Beautiful. This was the best. Okay, now do your homework. Goodbye.